Okay, this is solutions for Orange Workbook, pages 129 all the way to 131. And on page 129, we're dealing with colligative properties. And what we should, I should remind you is that if I have water, the freezing point of water is 0 degrees Celsius. The boiling point of water is 100 degrees Celsius. The moment I add something, I add solute added to water. So now it's a solution. It's a solution, homogeneous mixture. What happens to the freezing point and the boiling point? The freezing point is lowered, the boiling point is increased. So that's why, because the freezing point is lowered, we call it freezing point depression. And boiling point, elevation. So why is salt put on icy roads and sidewalks in the winter? Well, let's go with the salt. They're giving us because it is ionic or covalent. Well, Na is a metal, Cl is a nonmetal. Metal, nonmetal make an ionic compound. So this is wrong. It's not covalent, it's ionic. And when I add anything, whether it's ionic or covalent, into water, what does it do? It lowers the freezing point, increases the boiling point. So what does it do to the freezing point? It lowers the freezing point. What occurs as salt dissolves in water? Well, as salt dissolves in water, the number of ions in the solution decreases and the freezing point decreases. Well, when I add salt into the water, salt breaks down to the ions. So when I just had water, had no ions. The moment I add salt, now what happens to the ions? The number of ions increases, it doesn't decrease. So we're going to eliminate choice 2 and 3. So the number of ions in the solution increases, check and check. But now what happens to the freezing point? The freezing point, it decreases. So the freezing point is not increasing, but the freezing point decreases. So the answer to number 39 is choice 3. Number 40, aqueous concentration of each of the following substances. Assume equal aqueous concentrations of each of the following substances. Which one has the lowest freezing point? So if they have the same molarity, what do we know? The greater the number of particles dissolved in water, the lower the freezing point, the higher the boiling point. So this one is covalent. Covalent, it doesn't break into ions. It just stays and it forms one particle. Same thing over here. This is also covalent, stays as one, but this is ionic. And it breaks down to Na plus, NOH minus, forming two ions, two particles. The greater the number of particles into the water, the lower the freezing point, the higher the boiling point. You're going to see that the first one is C2H12O6. The second one is CH3OH. One particle, one particle. Choice 3, it's C12H22O11, so therefore one particle. Choice 4 breaks down to Na plus, NOH minus, two particles. Which one gives the greatest number of particles? Choice 4. The greater the number of particles, the more they kind of interfere with the boiling point and the freezing point. Therefore, they lower the freezing point even more. So that's why the answer is choice 4. What occurs when sugar is added to water? Well, when sugar is added to the water, what happens to the freezing point and the boiling point? Freezing point decreases, boiling point increases. So the freezing point of the water will decrease, yes, and the boiling point will decrease? No, it's going to increase. The freezing point of the water will decrease and the boiling point will increase. That makes sense. Let's see, the freezing point will increase? No. The freezing point will increase? No. Therefore, 41 is 2. 42, which one has the greatest, the highest boiling point? So we're going to see this is 1 molarity and this is 1 molarity. So we're going to eliminate this. We're going to go with the highest molarity. And we're going to see that this one, so this is 2 molarity. And this one breaks down to K plus and NO3 minus. So how many ions is it forming? 2. So 2 times 2 is 4. The molarity is 2. Now the CaNO3 breaks down to Ca plus 2. And how many NO3s? 2. So how many particles? 1, 2, 3. 2 times 3 is 6. The greatest the number of the concentration, the greatest the number of particles, the lowest the boiling point, the highest, the lowest the freezing point, the highest the boiling point. That's why it's choice 4. Let's clear all our drawings. Which property of a distilled water solution will not be affected by adding 50 milliliters of CH3 in water? When I add something to the water, it's going to increase the boiling point. It's going to decrease the freezing point. Okay, it's going to increase the mass because I started with 100 milliliters of water. I added 50 milliliters of that. It's going to be 150. The conductivity is not going to change. Why? Because this one is not an electrolyte. It doesn't produce ions. It's covalent. Therefore, it stays together. It doesn't produce ions, and it's not a conductor. And we're going to talk about electrolytes later on when we learn about acids and bases. Let's move on now to table H, vapor pressure. We talked about vapor pressure before. So for this one, we're going to go to table H. So let's go to our reference table H. Oh, there we go. Went too far. Okay, there we go. Let's decrease that. And what is the vapor pressure of water at 105 degrees Celsius? So let's go over here. 105 is over here. It goes up by 5. Let's find our water. It's over here. So let's go across and we're going to see, now it goes up by 10, 110, 120. So 120 kPa. So the answer is 120 kPa. 45. As the pressure on a liquid is changed from 100 to 120 kPa, the temperature at which the liquid will boil does what? So let's go to our reference table. And it says, as the pressure on a liquid, now this doesn't have to do, if we go to our reference table, we're going to see that temperature is over here and vapor pressure is over here. So that doesn't make sense. But now, so table H is not helping us. And it doesn't hurt for you to go back and confirm it. So if I have a liquid, and we know that for a liquid to boil, the vapor pressure over here has to be equal to the atmospheric pressure. As now we add more pressure, it goes from 100 to 120 kPa as we increase the pressure. What's going to happen to the temperature at which the liquid will boil? Well, the temperature, we're going to need more heat, more energy to increase the kinetic energy for the molecules to move faster and be able to escape this atmospheric pressure. So the boiling point will increase too. 46, in a closed system at 40 degrees Celsius, a liquid has a vapor pressure of 50 kPa. The liquid's normal boiling point would be, so let's go to table H. And it says we have 50 kPa in a closed system at 40 degrees Celsius. 40 degrees Celsius, so let's go over here. 40 degrees Celsius and 50 kPa. We're over here. A liquid has a vapor pressure of 50 kPa. The liquid's normal boiling point would be 60 degrees Celsius. Okay, so we're going to see here that now this is the point that we have. And let me just be able to write. I'm sorry, I had to do something. Okay. And now they're saying at 50 kPa, okay, the liquid's normal boiling point would be, if this is the point, the normal boiling point is going to be at 1 atmosphere. And if we go back to our choices, we're going to see that the normal boiling point is going to be at a higher temperature. So if we go back to the choices, it's not a good question, but what are we going to do? If we go back to our question, and let me just move my mouse. Let me just clear. So we're going to see that all of the answers are below 40 or 40. So the liquid's normal boiling point would be at a higher temperature. So it's not going to be at 10, 30, or 40. It's going to be at a 60. This, we did go on table H. It didn't really help. But you have to realize that in order for you to have a normal boiling point, it has to be, the pressure has to be 1 atmosphere. And it's going to be higher than 40 degrees Celsius. And the only choice is choice 4, 60. If the pressure on the surface of water in the liquid state is 30 kPa, the water will boil at, so let's go on our reference table. Let's clear our drawings. Let's go on our reference table. And let's see if the pressure on the surface of the liquid is 30 kPa. So I'm going to go 10, 20, 30 kPa. And I'm going to go across until I find water. And water is over here. What will the temperature be? If I go over here, I'm going to see that it's 50, 55, 60, 65, 70. So we're going to see the temperature of the water has to be 70 degrees Celsius. So this helped with the answer. A sample of ethanoic acid at 100 degrees Celsius has a vapor pressure of, let's move on. A sample of ethanoic acid at 100 degrees Celsius. So let's go to 100 degrees Celsius. Let's go and find ethanoic acid. Let's go across, and it's going to have a vapor pressure of approximately, we have 100 degrees Celsius and ethanoic acid. We're going to see that it has approximately 56, but they're giving us a choice of 53. So we're going to go with 53 because all the other ones are way too far. The closest one is the 53. Question number 49. Which substance has the greatest intermolecular forces between molecules? We're going to go back to our reference table. And what did we say? We said, the highest the vapor pressure, the lowest the intermolecular forces, the lowest the vapor pressure, the strongest the intermolecular forces. And which substance has the greatest intermolecular forces? That would be over here, and that would be ethanoic acid, and ethanoic acid is a choice. And we're going to pick ethanoic acid. The vapor pressure of ethanol, at its normal boiling point. So ethanol and normal boiling point. So normal boiling point, we said it's over here, and it's going to be ethanol, and ethanol is over here, and we're going to go down, and we're going to see that it's approximately at, it's asking about the normal boiling point, what will be the vapor pressure. So they're not asking for the boiling point temperature. The boiling point would be 80, but they're asking for the vapor pressure, and the vapor pressure is going to be this one over here, which is the dotted line. So it would be 101.3 kPa. So if we go over here, we're going to say that's 101.3 kPa. I hope this was helpful. Study and ask questions if you have any. Thank you.